Well, hi and welcome to my shop, and thanks for joining me here. It's April 25th and a super sunny day. It's fantastic, but it's only like 2 degrees outside. It's cold, but the sun is hot. Yeah, the sun is coming. So, first off, I must admit, I made a mistake. The last video at the end, I was pondering why I was getting such a low current reading on my current meter here. And yet the radio was operating and nothing, this didn't make any sense. Well, thank you, Mr. Viewer, for an email that twigged me on my error. I knew I was doing something wrong because the reading I was getting is just inexplicable. 40, what was I getting? I can't even remember now. 40 milliamps when there should be 125 milliamps flowing. And yes, I did something foolish. I set up this current meter to read the current through the field coil. And that's what it's doing. It's reading the current going through the field coil. But it's never reading the current going through the bypass resistors because they're bypassing the field coil and bypassing the meter. So I think I'm going to go with the 40 milliamps. Actually, I'm going to rearrange this and we're going to make a measurement of the actual current flowing. And I'm going to do it by interrupting the output wire from the power supply, this little wire here, and letting the ammeter get in line with that wire. I guess that's the way to put it. Then we'll see for sure how much current is actually flowing. And of course I don't really know what the current is here, but I will. If it's 40 in the other leg, it's going to be the remainder in these two legs. Okay, that's my plan. Yeah, I feel better now. Okay, we're ready for the test here. I've reconnected the ammeter now. It's now in line with the total amount of current flowing through the two resistors and the field coil. So that'd be the total radio B plus current, according to the schematic, 125 milliamps. The other oddball here that I've been picking up on is the apparently very low B plus voltage in a radio that's operating quite well. That's another mystery. I still have my meter connected. It's definitely on DC. And it's over here, DC plus and 500 volts. I mean, so the expectation is the B plus is around a little over 300. That would put the meter up around here, but typically it's coming up around 200 if I remember right. Do I remember right? I don't even remember right. So let's set this ammeter before we turn things on. And we're expecting 125 milliamps, so this scale should be fine. And I'm guessing there's a hidden 1 here, I guess. 1, 2, 5. I'm guessing. Okay. Yeah, of course they don't want to fit a 0 in here. It's too big. So they have just and they can't let the 1 be lit all the time or it would be there. So there's an invisible 1 here. That's got to be what's happening. Jim, do you know how ammeters work? Yes. Here we go. Volume down. Just making a last check. Here we go. And it's not plugged in. Okay, hold on. There we go again. 125. 315. And the set's not turned on. Okay, let me just double check that fact. Yes, I don't have the switch on. Okay, we're going to switch it on up here. Dim bulbs in. Now we're cooking. The fact that it's negative doesn't mean anything. I just have the meter hooked up that way. So B plus reading is, see, it comes up to 150 volts and then drops back. Oh, that's crazy what it's dropping back to, 50 volts. It's going to go up again, I think. We're feeding 77 volts into the radio. It's not very much. Okay, it needs more. It needs more. me turn this down a little bit here and give it the. So now we're giving it, looks like just under 90 volts. Okay, it seems to have steadied out there. Still, it's under 90. That's just a little too low. $100 volts. Still not terribly happy with that. Let's go higher yet. 110, 111. You should hear this. Yep, there it is. So we're up close to 100 milliamps now. Supply voltage 111. B plus at 200. That's enough to make tubes work. That's not 315 though. 315's up here. Okay, so we're at 111. Let's go to 100 and something more. That's 120. That's about as high as you would expect out of somebody's outlet. In today's world, in North America, we have overcurrent now. Oh, this is a new concern coming up now. Yeah. How did that happen? 150 milliamps now. I wasn't expecting that. Did I do too good a job? Let's cut the voltage back a little bit. Because 120 is a little high. That's too low. Let's try that. 115. This is still going up. Or did it jump? I didn't watch. Maybe it went down and it's going up a bit again. Well, it's a new concern. Where's all this current going? That's an interesting question. This is actually a very interesting test. I got to write down 115 supply volts. 115 supply. You know what? I heard this just now on the TV, listening to two experts talk, and they're talking about the effect of modern AI, the AI that's coming at us like gangbusters, and its effect on the middle class. Oh, it could restore the middle class. And I'm thinking, you guys you're talking about nothing. What do you mean? There's no supervisors? You need supervisors? Yeah. So let's say that's 150 because it's 150. 150. Something's cooking. These resistors got to be frying in here. They must be frying quickly. Let's take a look. 151. You know, all this kind of stuff could be hidden from view, right? When you don't operate a radio with a ammeter in the circuit normally. Oh my gosh, I gotta hurry. Those resistors are cooking. They are cooking. They are blowing up now. What are they? 155 degrees. Kapook! Well, who needs an ammeter? You can tell what the current is just by the smell. Okay, I gotta get out of here. Too smoky. Fumey. Okay, so just thinking about this off the top of my head, which is how everything goes in here. I'm always just working off the top of my head. So an interesting question. Too much current flowing here. That current is flowing somewhere in the radio. There's only 200 volts behind it. How can you have 200 volts, a low B plus instead of 315, and drive that much more current into this radio? So maybe the answer is there is something pulling down the B plus voltage and sucking back the current in here. Could be a thing, could be a bunch of things, could even be vacuum tubes doing it. Not sure about that one, but I'm just not sure about any of it. So what comes to mind now is trying to trace down the heavy current, trying to localize, what part of the radio the heavy current is being drawn from. Another thing too is that current, it's got to be generating heat somewhere. I haven't noticed anything else getting hot in here, which is the only reason I would suspect a tube. And why would a tube suck back a bunch of current? incorrect bias. So why would the bias be off? Old ratty capacitors. I mean, there is a story to be told there, but is it really true? I don't know. I don't know. Is it really true? I'm going to think about this a little bit, drink some coffee, and we'll try something else here. So a few videos ago, when I was working on this radio, I temporarily hooked up a power supply, a high voltage power supply, to take the place of the internal power supply, drive some current into the radio and see how much it was. And really I was looking for gross shorts in the B plus circuitry in the radio. I did that with the tubes not operating, no heat in the heaters, and I got a sort of uninteresting result. I didn't know what to make of in particular. I'm going to repeat that again. The reason here is it's inexplicable to me how this radio can draw the kind of current we saw on this meter with only a couple hundred volts of B plus when it really wants 300 volts. You know, that's a huge increase. That would increase the current even far beyond the 125. So I am thinking something must be pulling it down. There must be some partial short in here somewhere. Something must be pulling it down. And maybe I can track that down without taking the risk of operating the radio with its full, somewhat unlimited power supply. I'll use my little power supply up here to do it. And something else just raced through my mind as I was talking, and it went right through it out the other side. So something else I was going to say. Well, whatever it is, I'll think of it again. So I'm going to set up to use the power supply up there to drive current into the radio, starting with the tube heaters off, and we'll think about turning the tube heaters on. Now, because I've separated things here with this ammeter, it's really quite convenient to at this point just hook up to this wire and shoot the power in. Shoot the power in. That's what I'm going to do. All right. Okay. I don't think this is too complicated. I think I have it correct. That's probably why I don't. Let's see. This is the... So I'm still going to run power through this meter. So it's going to come out of here. This is connected to the power supply above. Down the long red wire through the ammeter and then on to the B plus feed wire into the radio. So and again, this might read negative. It really doesn't matter. And we also have a couple more current meters to keep an eye on now, or at least a couple more meters. So if this is a current meter, you're going to have some trouble seeing it. Well, what if I do this? Let's just see what happens here. Yeah, how's that? That's a little better. Okay, probably that frame rate. No, it's still up. How do you like that? So you can see the pointer on this meter. Now, there's a red line right up in this part here, about 2/3 of the way over. But you're not supposed to go past the red line, at least for any length of time, or it'll overload the power supply. This red line is occurring at 100 milliamps. Oh, that's a problem, isn't it? This is more than my supply can give. Well, I can just keep the B plus voltage low. The B plus voltage will be on there. Keep it low and keep the current within limits that I'm not worried about. So probably bringing it up to 75 milliamps is probably the highest I would want to go. If I can even get there. Last time I did this test, tube's not operating, I got almost no current flow, and it reassured me that there were no significant shorts in the radio. So we're kind of just repeating that. I think I'm going to get the same result out of it. Put that on standby. Give it a moment to warm up. And this is still reading the B plus voltage down here, way down there. So I have a more accurate idea of the B plus voltage here. The meters on my old device there, they're not very accurate. Okay, I'm sure that there's enough. I'm sure it's warmed up now. Okay, I think I'm going to step forward. I'm going to block view of things a little bit. Okay, this is down. This is the voltage control here. Okay, voltage is on. Now it's usually a little shot that takes place when you first turn this thing on. I think you could see this pop up briefly. Okay, let's go. So I'm going to keep my eye on this meter here because this is the one that's kind of protecting the device. So what's happening, you probably can't see this, but the meter was popping up a little bit and then coming down. And it's just charging up capacitors. So we already have 150 volt scale. We got over 100 volts here already. And the current flow is all of, can't even see it. This is now 20 milliamps. I guess this goes 19999. That's the 20 limit on there. So there's virtually no current flowing here. Virtually nothing. And this meter shows nothing. Okay, we'll push the voltage a little higher. I'm getting the same result I got before. So we're up around 250. Yep, right around 250 volts now. Now there is some current flowing. Last time I did this too, I had these resistors get hot here. And I thought that's, when I looked at the, when I operated the radio normally, the resistors down here did not get hot at all. So that left me wondering what kind of mistake I had made. So is my battery gone dead? Uh-oh. She doesn't want to go. I think maybe I left this plugged in and on all this time. Yeah, my battery's gone dead. Okay. So this is 0.03 milliamps. 0.03 milliamps. That's a tiny current. That could easily be, oh yeah, I was worried about these resistors down here. A little too much voltage for me to stick my finger on them. I have to run around the house to get another battery for my, I'm going to do that. I'm going to leave this running for a while, let some heat build up somewhere, and we'll see if we can find it. Okay, so when I said the heat build up, I should have said temperature build up. Now, I've got my thermal gun now. Thermal viewer, not a gun. I have a thermal gun. So I've looked this thing over already fairly thoroughly, and you know, with this tiny current, you know, what could you possibly see that might be hot? And what I started seeing, again, this is not showing up so well on your camera, your screen. Can you see there's something there? I thought, oh, it's this meter. The meter's the hottest thing in the room. How could the meter be hot? But as it turns out, it's not. The thing that's warm in here is that device there. This thing. That's the thing that's warming up in my shop. And again, I'm sorry you can't see the screen on this guy. It's probably not warm. It can't feel a thing. So I mean, I've got this set very sensitive. So any little bit of heat, this thing's going to find it. But there's nothing. There's nothing at all. And how can I be surprised? There's virtually no current flowing. I'm not going to get heat with no current. So the question then is, does that mean that this heavy current flow is all through tubes? And if the answer is yes, then does that, and I think that would be the answer, then the heavy current flow being, you know, through the power supply properly, does that mean one of the tubes is misbehaving? Does that mean one of the circuits is misbehaving? So the tube is being beat up, basically, which is quite possible. Now, interestingly enough, the schematic gives current flow numbers for the cathodes of most of these tubes, if not all of them. The idea being you'd interrupt the cathode wire and then stick an ammeter in, just like I've done here, and then read the current to that tube. That's an awful long ways to go to figure something like that out. Another possibility would be, and bearing in mind that back in 1940 nobody had anything like this in their hands, that's for sure. Could it be the case that a bad acting tube would show up much hotter than the rest? If it were one tube drawing the excess current, let's see, the biggest current drawn the tubes in this radio is 40 milliamps through the output tubes. What if one of them was sucking back all the excess current, which is another 25 milliamps? Well, that would be 65 milliamps instead of 40, and I'm sure that would show up in the heat of the tube. You could literally look at it with this viewer and go, hey, look at that tube. Now, this is a push-pull circuit. There's a pair of push-pull tubes. There's a pair of drivers. And it could easily be a condition where the circuit is causing the pair to misbehave. So both tubes in the pair are drawing too much current. How would I know that? If I look at it with this viewer, I don't know what it's supposed to look like. So I'm going to see one pair elevated, let's say. How do I know that that's a problem? I wouldn't even know. If it was one, then I'd know. But it's not. If it's two. I'm just thinking this through. Trying to build up the hypothesis before I start the experiment. Not good to do experiments without a hypothesis, by the way. That's akin to stumbling forward. You don't want to be doing that. You want to try to avoid that as much as possible. I could be in a situation where I got to try it and see. Now, can I operate this radio in such a manner that the high voltage tubes get their voltage only from my little power supply and the tubes are heated up? Well, I think the answer is yes. This is exactly what this guy is actually meant to do. He's meant to replace the power supply in radios and operate the radio from there. To guarantee that there isn't current going in the wrong place or something terrible happening. How do you guarantee that? Start slow, low B+, bring it up slow. How do I keep the B+ from the radio itself, its own power supply? A couple ways. One, I've separated this wire, so that could be it, but I do see there's a resistor sitting here. I don't know what that's really all about. Could pull out the leads to the field coil. That's just the same as cutting this wire. No, it's not anymore because I have these resistors in, so the resistors would remain in, so it wouldn't actually be the same. So I'm just trying to think up what it is that I'm going to regret. I'm trying to think it up ahead of time. There's an anti-regret move here. Well, because I can raise the B+ slowly, speaking of which, I bet I should really drop it while I'm standing here yapping away. This is going wild because the charged up capacitors are discharging backwards through it. Backwards? Would it be backwards? Discharging anyway. Discharging backwards through it. Man, I don't know if there's any truth to that statement. Put my supply on standby even. Yeah, it's on standby. What's happening here? What's happening? Hey, what's going on? There's a voltage coming up and down here. Everything should just be going down, down, down. Okay, it seems to be going down now. Well, that was pretty weird. But I'm not going to pursue that at all. Definitely strange stuff, though. Unless I'm just maybe I didn't see it for what it really was. Okay, so firing up the heaters amounts to just, at this point, turning on the radio. Because no B+ can go anywhere, but there is this resistor here. We got to look at the power supply. Take a look at this resistor situation. Just look at the power supply. Look at the schematic, rather. Okay, and now before I make a video mistake here, there we go. There we are. Success. You're looking at the schematic. Okay. We want to look at the plug here and identify where the resistor is. It's on one of these two fat lines. So let's go this way. Follow along. Nope. Could be that. 47K. 47K. And you know what? This looks more like 2700 is what it looks like. 2700. Let's look and see if we can find something like that. 220. You know what? It could be that. Because I'm looking at it here in the dark. I don't think so. I think it's a 27. Look at all the resistors that are along here, though. 15K. Oh my gosh, this just goes on forever. 39. Well, it answers the question anyway. I mean, a lot of these resistors might be going to places where there can be no current flow. Anyway, am I worried about nothing? I'm worried about current traveling through this resistor and me not knowing it and something happening. Yeah, I'm not gonna. Okay, enough of that. Enough of that. Yeah, I don't want to say I'm being overly cautious, but I keep an eye on this somehow. Okay, so we have no B plus right now, and if I turn the radio on, this meter should stay 0 the whole time, because there should be no B plus reaching it. Maybe that answers the question right there. If somehow B plus is leaking through this resistor and getting there, can it even happen? I don't know, I'm not even thinking. Let's just do the thing. Okay, turn down that. Heat them up, Jim. Okay, I'm going to put this a little more sensitive. 50 volts here. Oh my gosh, look at this. Look at this. How's this happening? What's happening here that this can happen? What am I not thinking of? I don't like the looks of this. I'm going to shut it off. So I think, how could that happen? The only way you can get current through this meter, this current is flowing through my power supply. Like, I think if I open this up, it drops to 0. So, without meaning to, somehow I reverse powered my power supply from here. Wow, this is really it's really a very simple thing, but boy, I just seem to be struggling with it like crazy. I could pull out the rectifier tube. Rectifier tube, is that part of the picture of the current? I don't think so. Let's pull the rectifier tube out of this radio here. I mean, how much more can it? Okay, we're going to try it again. Yes, we're going to try it again. Here we go. I had current flowing almost right away, didn't I? Put that tube in. The tube would take a few seconds to heat up anyway, especially with 81 volts on the radio. Okay, well, we seem to have solved this current thing. So I want to raise the voltage up close to normal operating voltage. I'm going to keep the dim bulbs in. Let's see, we're up 96. Let's get like 105 on it. You can see this glowing a bit. That's from the current through the heaters, I would imagine. Not much more. I heard a sound there, but I think I just brushed up against something here in my shop. I thought I heard it come out of there, but I think. So we got a 0 here. That's good. We got a 0 here. That's good. By the way, the radio should operate. When I raise up the B+, it should start making sound. So we're feeding it with a little over 100 volts. And as it is, there's not a sound, of course. Volume down. Okay, we're going to bring on the B+ now. So bring in the B+. We're watching this meter. The last time I did this with the tubes cold, nothing here. From the power supply, it was 150 milliamps. put it like that. And I can control the B plus. Okay, here we go. So, okay, a little jump there is my supply is still set to 0. You can see it on this meter over here. Okay, here we go. Let's take it up. Get there without. I don't want to step in front of the camera, but it's a little hard not to. Yeah, I'm gonna have to. Voltage up. So no current showing on the current meter up there. No current showing on the current meter here. Oh, this isn't good. And the actual voltage I'm putting on those tubes is all of the 30 volts. Yeah, it's just not enough. 30 volts, not enough. Yeah, my other meter agrees. 30 volts. But I'm not getting any current here at all. A little worrisome. I'm doing something wrong again. But I don't know what that might be, so let's keep going. There we go. Okay, up around 100 volts now. 85 volts, no current at all. This is not working. I'm doing something wrong. What can I be doing wrong? 0 current. Is it really 0? Wow, it really is 0. Wire not connected. We haven't heated the tubes up enough. Look at the light bulbs, they're just beaming, so the tubes are too. We're at 100 volts. It's just well, I'm glad I had a hypothesis. Something stupid is happening here. Once again. A wire not connecting? Well, if the wire wasn't connecting, we wouldn't get this voltage. So I'm jamming on the plate voltage. You know, could be that I'm only energizing part of the radio here. I don't think so. I think it's a... Let's just leave it sitting there and take a look at the schematic here. So what I've done is I've interrupted this wire right here. Yeah, look, there's a whole power supply thing coming off of here. Are they not connected in some way? So we come up here, come around. Now we're on this wire. They are connected right there. I should read the same voltage at the top of these other capacitors. It's a little weird. This one's rated at 450 and these are only rated at 300, yet they look like they're wired solidly together. Well, they're not. No, they have the field coil in between. Oh, right, field coil dropping voltage, and I'm bypassing the field coil here. So I should not try to supply 315. I should be trying to supply 230. Oh, what is the voltage right now? Voltage is 85. Well, I could push it up to 230, and I could check. I could read the voltage on top of this capacitor just to be sure it is the same as the supply here. It should all be the same. Should it? So I've interrupted this wire, and yeah, I haven't interrupted this wire. The wire I've interrupted is actually this wire here, I think. I've interrupted the wire that has the... Oh, okay. Maybe I got this totally wrong. Yeah, I may have this totally wrong, what I've done. Okay, shut down everything. Shut her down here. Okay, I'm going to stop for a while and study this a little more carefully because I really think I'm messing up in how I'm connecting this, and that's explaining why the test is giving unexpected results. So I need to stop for a bit. Okay, a little bit of a different approach. Now I have this tube pulled out. So what I can do now is I can use my power supply to power the circuit right where the tube powers it. It's right on the top of this capacitor. So all I got to do is just hook up my power supply basically to the top of this capacitor or this pin, which incidentally exactly the same spot in the radio. Power it through here, make sure the field coil is in place, and I will distribute B plus exactly the same way the radio does, and I won't miss this leg over here or something else going on. Well, let's try that. Okay, let's try that. So all I got to do is, instead of powering it here, I'm going to reconnect this wire where it came from, and let me just pull the plug out here. Restore the circuit the way it was with the tube out, feed the power in. It can be either end of this wire. You know, I'm only assuming this wire goes where I think it goes. Well, I don't have to assume anymore. I can see it go there. It goes to the top of the capacitor over here. Yeah. So I'm getting the willy-nillys about this, but I really shouldn't. Let's just make sure our power supply is on standby. And so reconnect the wire and connect the pot. Now I got it. Okay, I think I got it. That's the worst thing of all. You think you know what you're doing? Terrible, terrible situation. So I'm going to feed this into the same spot over here. With this very awkward clip. Okay, then I'm going to solder back this wire over here. Can you guys hear my stomach growling? Hey, what's with all those gigantic microphones I see people using on YouTube videos? Everybody wants to have a microphone shoved right in their face. What are they doing? Yeah, if I want to do that, I've got microphones galore here. I got a box full of them. I can bring them all in and spread them all around so you can see them while I'm talking. Come on. Let's just do this. Okay. All is normal, except the rectifier tube is pulled out. Feeding the power supply B plus through this ammeter up to the same point that the normal power supply feeds it to. And I think I got it. Really? So a little bit of a change here. Why don't we just power up? Let's put some voltage on here and see what happens without the tubes heated up. So again, you got B plus here, got a current flow there. Here we go. So that's probably a charging current. Oh, it's not falling all the way to nothing. Well, that's 2 milliamps. Oh, I'm sure I just heard some weird sound here. It's probably my stomach again. Okay, so the amount we're feeding on here, B plus wise, is a little over 100. I'm going to take it up to around 250. That's 250. Don't bit of a charging current there, but it's not going to zero. Now, presto. So, interesting enough, now these resistors down here are getting hot. How hot? 40 degrees C. So I noticed that before. So that's where a chunk of current is heading. Well, I have to be a fair bit of this current is heading through these resistors. What's going on there? Pretty sure when I operated the radio in the normal way, these resistors did not get hot. They did not get hot. Yet when I do this power supply thing, they're definitely warming up. It's now about 45. But that's almost certainly where the current is going. It's not leaking through capacitors or something like that. Okay, so now we're going to fire up the radio's heaters. Rectifier tube's still out. And we're going to see what we end up with. So here we go. Nope, we didn't go. Gotta plug it in. Okay, here we go for real. So this could go up to 125. If it did, it would be a thumbs up, I think. Let's see what happens here. It's going up. Don't be afraid now. We are getting up in the range of 125. Now, this looks pretty good. So the 250 is what you expect on the far side of the oh, this is showing normal operation. That's why the radio's been operating normally all this time. Well, that is excellent there. We're at 250, which is roughly the B plus that's expected. Now, pretty good. Ooh, what's all that stuff? Short in the capacitor? What's happening there? I say that a lot in this shop, don't I? What the heck's happening? Where's the pops? No pops. Look at this, is coming almost exactly, or 125, right on the money. Okay, don't know what those pops were. It could easily just be a loose wire in what I'm doing here. Doesn't seem to be though. Yeah, I think for fun, I'll hook up the antenna properly to the radio. We're going to try and listen to it a little bit. So my antenna is switched off right now. I got to clip this on. The wire's hanging out the back here. Ho, 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 just blew my ears off. Right. That was stupid. You'd think sooner or later I'd get to the bottom of the list of stupid, but it seems to me it's just, there's always more. So this is not connected to an outdoor antenna, but it's close. That's pretty good. This is a community radio from Toronto. It's a relatively strong community station. I'm going to run and flip the switch on and we'll see just how much louder this gets. I'm going to leave it up a bit. And we're only supplying 101 volts, so the heaters are a little low, but that's okay. Obviously it's working. These resistors, can these things be getting hot now? I smell something. Yeah, these resistors are pretty hot. 160 again. And that just shows that this is behaving the same way it behaves when the full power supply is operating. Same stuff is happening. That's crazy hot though. 160. That's just not, that's why I can smell it. Anybody else? Quickly, anybody else? Anybody else heading up there? No, there's nothing else in here that's anything like those two resistors. And what about these little guys over here? They don't even show up in comparison. Wait a minute, how come these aren't hot now? They were hot earlier, were they not? Oh, look at that. Can you, I know you can't see any of this on this viewer. I'm pretty quite disappointed, but we are cooking these resistors right up. So power off. Well, turn the heaters off. As they cool off, you'll see this current drop. And the radio go quiet. Good. I'm going to stop for a bit, let things cool a little bit. I'm going to turn on the antenna and we're going to play with the radio a little bit. We can get away with a few minutes. Okay, let's try this again. This is probably cooled right off. Still a little bit of heat there. 40 degrees centigrade. Let's turn the radio back on. I got the antenna switched on this time. Don't touch the volume. I want to compare a little bit. Surely to goodness it'll be a lot louder. I lowered the B plus when I left, so the B plus, here it comes. So this probably won't come up all the way to 125 now because I have lowered the B plus. It's interesting how you know, like running low voltage on the heaters, only 100 volts. Transformed down, of course, so it's probably like 5 volts left for the heaters. The B plus I've got low at about 160 volts or so, 170 volts. How low can you go with the B plus? Let's go down. B plus going down. Okay, volume up. B plus down. Volume full. Oh, hear the distortion. Go down a little lower. Interesting. Okay, volume. Okay, the normal volume might be something like that. Up with the B plus. And that's pretty much the normal B plus there, 250. So current flow is kind of almost normal. There we go. I'm one of those people. Let's turn this down. Oh, well, you know, I didn't notice. Oh my gosh, this is up, my current flow up here is well above the red line. Shame, shame, shame. Let's stick it about there. 75 milliamps on that meter. Oh wow, accuracy, unbelievable. 75 milliamps. Okay, that's a safer thing. I wasn't watching. There's no alarm. Let's go tuning. The long arm of the law. That's what we're seeing. Hey, come on, keep going. Don't stop.
And at the same time, this is all going down. Jagmeet Singh says, well, he's thinking of personally.
Jagmeet Singh is a significant political leader in Canada.
To use the platform as a party, so our party is
well, that's him.
on the platform, and on my personal side, we're making that consideration of how to get back on it.
In Canada, we have 3 significant political parties and a couple others struggling on the fringe, and he's the leader of one of the 3 significant parties. Long history. Well, it receives nicely. Like, the radio's actually working quite well, except for the tuning. But I think I can fix this tuning situation by just tightening a spring in there. I think that's where that would go. Okay, what am I determining here? I'm determining that actually everything seems quite normal, except because of the incorrect field coil and my anxiety about overheating this field coil, I've ended up introducing 2 resistors that are overheating here. They can't leave this the way it is. Short term, I can get away with operating the radio. I can get away with operating it like this and keep the B plus low. Things don't get too hot. How hot do they get? Only 85 degrees. Still pretty hot. You wouldn't want to touch those. But 85, I think these can run at 85. Not the end of the world. So actually, I have a way to operate this radio now. All the tests seem to suggest that the capacitors are not leaking badly. There's nothing in here that's really... I'm not suggesting they shouldn't be changed out, but there's nothing in here that's really, other than the one that fried up over here much earlier, nothing else is sucking back the power. How do I know that? Because if you turn the heaters off, the current drops to virtually nothing. Now that's interesting. If you turn the heaters off, do these resistors warm up? Is that kind of what's going on here? So that's... I'm going to make it possible for you to see that thing. How can I do that? Maybe with this. So bear with me a moment here. I've got to fix the focus on this so it won't vary. Ooh, what was that? Something went pop and the radio's volume changed. I don't know. Focus here, and we're going to put it about like that. And something weird is going on here. Here we go. Something weird went on there. Take the camera. Take the camera and hold it in some weird way. Just bear with me here. A little out of focus, but now you can see the red stuff anyway. There's the 2 hot resistors. And that's at 85 degrees. That red is 85 degrees. And there's nothing else in here really to show you. The rest of the stuff is, look at my, yeah, nothing else to show you. So that was it. Okay, not the best. You know, not the best demo there. Good. Well, I'm gonna stop. I may stop for today. I gotta figure out what to do about this situation. Yeah, gotta think about that. I'll stop for now. I think I'm going to call it quits here today because with the beautiful sunshine, I got to get outside and do outside stuff while I can, because you never know when the gray, crummy skies are coming back. So thanks a lot for watching. I think tomorrow I'm going to be trying to resolve these two resistors again. Somehow, I don't know how, but I'm getting closer and closer every day. Okay, thanks a lot for watching. Have a great day.